Hello everyone. We have a question. Find the coordinates of the point of intersection of the curve y is equals to x power 2 upon 3 negative 1 with the curve y is equals to x power 1 upon 3 positive 1. So basically we have two equations of the two curves and we need the point of intersection. And when we say the point of intersection means the common point for both the equations. Because x power 2 upon 3 and x power 1 upon 3, that means the power is in fraction form. Definitely we cannot solve it in this form. We will go for a substitution process. Because the power 1 upon 3 and power 2 upon 3 can be compared, so we can go for a simply substituting. We can take any variable other than x and y because they are used in the question. You can take any variable, like I have taken a over here. A is equal to x power 1 upon 3. When I have written a is equals to x power 1 upon 3, that means instead of this x power 1 upon 3, I can write a. But over here we have x power 2 upon 3. That means this 2 upon 3 can be written as 1 upon 3 multiply by 2. And when we write 1 upon 3 multiply by 2, that means instead of this x power 2 upon 3, we can write a square. So we have done the same. Instead of y is equals to x power 2 upon 3, we have written y is equals to a square minus 1 y a square, because x power 1 upon 3 is a, and if we go for squaring this one, this squaring a square and squaring this, it would become 2 upon 3, and definitely it is 2 upon 3 over here. This would become a square minus 1, it is over here, and the second equation of the curve is x power 1 upon 3 plus 1. So instead of 1 upon 3, we have a plus 1. Because it was about the point of intersection, as I said, it is a common point. You can equate both the equations because both the equations are in the form of y. So we can write a square minus 1 is equal to a plus 1. After writing that, rearrange it and a proper quadratic equation in the form of a is formed. Now use the quadratic equation and get the value of this particular a, because a is the substituted variable. So use the values of the coefficient of a square as 1, which is the value of a according to the quadratic formula. The value of this a is negative 1, which is the value of b according to the quadratic formula, and the constant is negative 2, which is the value of c in the quadratic formula. Just use these three values, positive 1, negative 1 and negative 2 for a, b, c. Place it in the quadratic equation, simplify it, and finally you have got the two values as 2 and negative 1. Keep in mind, these are not the final answer. These are basically the two values of a, and a was the substituted variable. That means instead of this a, I can write x power 1 upon 3 as 2 and x power 1 upon 3 as negative 1. So let's go step by step. If I take x power 1 upon 3 as 2 and x power 1 upon 3 as negative 1, basically we need the x coordinate, so we have to remove this 3 which is there in the denominator of a fraction. For that we will go for cubing both sides. So cubing both sides over here would result in simply x, and 2 cube would become 8, and now we have got the x coordinate of one point of intersection. And similarly cubing over here, and minus 1 with the cube would again give us negative 1. That means the second point of intersection of both the curve will have an x coordinate negative 1, because they have not told us just find the x coordinate, they have told us find the coordinates of the point of intersection. That means we also have to find the value of y coordinate. We have the 2x coordinate. You can use any of the equation, whether the first one or the second one. You can use any of the equation, place the two values of x in the given equation, solve it and get the two values of y. If we take the first equation, which was y is equals to x power 2 upon 3 minus 1, we have taken it over here, and instead of x we have written 8 because this was the value. convert this 8 into 2 cube so that this 3 and 3 could be cancelled out, and then take this 2 as 2 square, which is 4. 4 minus 1 would be 3. The y coordinate is 3. That means one point of intersection. Finally, we have found the x coordinate is 8 and the y coordinate is 3. Similarly, the x coordinate of the other point of intersection is -1. So use the equation, any of the equation. We have taken y is equals to x power 2 upon 3 minus 1. Instead of x, just write -1. As you can see, when we took -1 with a cube, we got the answer as -1. That means instead of this -1, we can take -1 with a cube. So I have done the same. Why I did? So that we could cancel this cube and cube. Now we are just left with this 2, and -1 with a square would become +1, and +1 minus 1 would be 0. So finally the y coordinate of the other point of intersection is 0. So finally we have x as -1 and y as 0. So the 2 point of intersections are 8, 3 and -1, 0 for the 2 given curves.